All right. Good evening. The date is June 5th. The time is 1800. And this is my first documentation video for this project. I'm surprised I haven't done this yet, considering I'm almost finished with the first prototype. But this is a 4-bar linkage robotic joint that I am working towards. The goal is to have a joint that kind of looks similar to this, that actuates on both ends of bars that can move and make a parallelogram shape that could hopefully make drawings, to have a pencil go through this end of the 4-bar and then the actuation on this end. That way it can move and make various geometries kind of in this kind of motion. The heavy lifting is just going to be on the coding side of it, but to start, the first step should be actually making the joint. So I have opted for a Capstan Drive. For those of you unfamiliar with Capstan Drives, it basically is a big screw with a cord wrapped around it. This cord, the friction between the cord and the screw increases torque output. So by how many revolutions you have around a screw of a certain string, you can increase your torque by a lot. So just a little bit of math I have done for this project. The idea is to have your screw with a string wrapped around it, and it wraps into this drum that has 2 tensioners on either side. The tensioners pull the string taut, which pulls the drum in, or pulls the screw in. And by my math, it should quadruple torque output, which is impressive. So as I previously stated, I have made a prototype, at least a somewhat functional one. I have yet to actually code it in order to see if it moves as I would expect. So here is the prototype. So getting a little bit more in depth with this is the general idea. It has the screw on one end that you rotate, and it pulls either end of the string either up or down. There is tensioners in there that you screw either head on these screw bolts, which will pull this paracord taut more. So that's the basic idea of this, and it's just all 3D printed on a simple test fixture with a really cheap encoder motor on the back that has a Hall effect sensor, so that way I can actually read what is going on in there, and I can know exactly what angle it should be at. This can move or have a range of 90 degrees, so all I need to do is actually code it and actually make it move up and down. The motor that I chose was the cheapest money could buy on Adafruit's website, and that is actually where all of the electronics for this project came from. The brains of this, so to speak, is an Arduino Metro RP2350. This has enough beef in it for what we're needing, and here I just have a simple OLED screen connected to it. That way I can actually read what is going on inside the brains here. And for this single motor setup, this is just a simple motor controller they had online. That way I could more accurately read or give outputs for what is happening to the motor. Now, in regards to the corkscrew that wraps to the drum, I have gone and made several different iterations of it. This being the first one with short heads and a short butt. The next one having a longer head and larger helix diameters. And a more recent iteration having no butt, long head, larger helix, and 2 mount holes for a collar to actually attach to the motor. And the latest revision is currently on and wrapped. It has 2 wrappings, so this will affect torque output. I can wrap it more, but then we lose more range of motion, but more wrappings equals more torque. For this project, since I'm wanting just to draw things with it, I am not expecting to get a massive amount of torque, at least out of this. So why choosing a capstan drive? I chose a capstan drive because it's non-axial, meaning I can have these drums. I can have 2 of them stacked on top of each other and be able to control either of them and move them in the directions I want. As shown in this very simple and rudimentary example, if these were my 2 drums and I can move them as I want, obviously it's a parallelogram shape, so either bar is going to be parallel to the opposing drum. So if I had a pencil on this side of the parallelogram, I can move one part of the drum and it shifts the pencil over here. Or I can move both sides of the drum and it moves in a straight line. So I can make complex shapes like squares, or I guess triangles, because I am not a robot. But in theory, this parallelogram 4-bar linkage design should make perfect shapes, either squares, triangles, or circles. That's going to be, as I mentioned, the most complex part. There is a lot of inverse kinematics there to calculate. With that being said, I have not coded 2 joints yet. I'm testing this one joint first to make sure that works. If this joint ends up working, I'm going to duplicate the design, maybe revise it a little, make a better testing stand for it to lay horizontally instead of in this vertical configuration, and then hopefully get this guy actually working. So yeah, with that, the last thing I got to touch up on for this documentation, the project budget. I'm expecting the budget is at maximum $150. And so far I've spent half of it, mostly on electronics. But the bulk of it has already been covered because most of it went into this Arduino and cables and wiring. All of the actual materials to make physical objects like these corkscrews or the drum has been 3D printed on my A1 3D printer. I've had more than enough filament to supply these at the moment. And yeah, so with that, I've been making all of these CAD models in Autodesk Inventor. And these have been frequently updated. As I've said, I'm on the first prototype of this, but not the first revision, because obviously I've gone through a lot of screws. But if I get a working prototype, I will make a video of it working. So, thank you. Okay, the time is 2000, same day, June 5th, 2025. And I have a controllable version of the first capstan joint. So here is the joint. It is wired to this analog thumbstick. As you can see, it is reading angles from that. If I turn up the voltage of my power supply, the motor will whine a little bit. It simply just does not have enough torque for the state 0, but I can adjust it. As you can see, it runs really smoothly. Though the motor seems to not have enough torque for some motions. And it also tends to get stuck quite frequently right there. to be worked out in revision 2, but for now that proves that the joint does work. So I will need to get probably a motor with higher torque or higher stall torque. That way it's not running itself dead every single time it's trying to move. And also update spacing, that way the collar does not interfere with the actual drum. But I gotta be honest, this is fun. Let me just increase that a little bit. Just going up and down, it's so satisfying to watch that. Unfortunately, it doesn't seem to be able to do it autonomously. I'm not exactly sure why yet, but hand-controlled seems to work just fine. So I will make some tweaks to this and hopefully get a 2-joint set up eventually. So, yay.